Hey guys, this is Mrs. Lyons, and here we are to work on. I'm going to give you a walkthrough of the homework in your packet, Stoichiometry Practice 1. All right, so if we look at this first chemical reaction that we have, you should notice that this is a combustion reaction. We know it's combustion because we've got a carbon-hydrogen compound reacting with oxygen. So this is a combustion reaction. And we know that the products of a combustion reaction are always the same. They are always carbon dioxide gas plus water vapor, so H2O gas. All right, so now we need to balance this. So let me find a piece of scratch paper. There we go. All right, so let's see. We have C3H8 plus O2 results in carbon dioxide and water. Okay, so I have carbon, hydrogen, oxygen. On this side, I have 3 carbon, 8 hydrogen, 2 oxygen. On the other side, I have 1 carbon, 2 hydrogen, 3 oxygen. All right, so I'm going to start by putting a 3 in front of the CO2. And then I have 8 hydrogen, so I'm going to put a 4 in front of the H2O. Okay, so now my carbon and hydrogen are balanced. I just need to deal with oxygen. So let's count. On here, in my carbon dioxide, I have 3 times 2, that's 6 oxygen, and the water has 4. So that's a total of 10 oxygen on the product side, which means I need a coefficient of 5 in front of the O2 to give me 10 oxygen. So this is a 1. Okay. All right. So let's see. And you know what I'm going to do? I'm going to write my mole map right here on a piece of paper that I can move back and forth. So remember, my mole map starts with grams of A. We can go from grams of A to moles of A using the molar mass of compound A. Then we go to moles of B using the mole ratio from the balanced chemical equation. And then we can go to grams of B using the molar mass of compound B. All right, on a test, you will get grams of A to moles of A to moles of B to grams of B. Okay, that's all you'll get on the test. But if you've practiced this, it shouldn't be a problem. Okay, so let's look at our problem. Our question is, if 5.11 moles of water are produced, how many grams of C3H8 react? So my given is 5.11 moles of H2O. My unknown is grams of C3H8. And remember, we said that we can just identify without writing it out our given. So in this case, water is A, C3H8 is B. Okay, so if we look at our mole map in this problem, we're starting with moles of A. So we're starting here. All right, I'm going to put a 1 here to represent problem 1. And we're ending with grams of B. So grams of B. So we're ending over here. Okay, so we're going from moles of A to moles of B to grams of B. So that is a 2-step problem. Okay, so let's start. So I have 5.11 moles of H2O over 1. Remember, using dimensional analysis, the units that we start with are always going to come down diagonally. So moles of H2O. And then on top, so we're going from moles of A to moles of B. Okay, so that's where we use the mole ratio. So on top, I'm going to have moles of C3H8. I didn't leave myself enough room to write. So then we look at our coefficients. So moles of H2O is 4, and moles of C3H8 is 1. Okay, so that's step 1. Let's do that math. So 5.11 divided by 4 equals 1.28. All right, that's moles of C3H8. Okay, now, all right, the next step is to go from moles of B to grams of B. All right, so this is what I start with. So moles of B, and then to get to grams of B, again, so remember, units are going to cancel, so moles of water cancel out. So we want moles of, if we've got moles of C3H8, we want moles of C3H8 over here on the bottom. And then on top, we want grams of C3H8 because that's what we're trying to find. So grams of C3H8. Okay. And this is where we use the molar mass. So 1 mole is always equal to the molar mass. So in this case, we have C3H8. So carbon is 12.01. So 12.01 times 3 is 36.03. And hydrogen is 1.01 times 8 is 8.08. Let's calculate this so I don't make a silly mistake. 36.03 plus 8.08 gives us 44.11. Okay, that is our molar mass of C3H8. So 44.11 grams. And see again, moles of C3H8 cancel out. So I had 1.28 times 44.11. Oops, that didn't plug into my calculator right. 1.28 times 44.11 is, oh, that's a big number. Oh, no, it's not. That would be 56, not a big number, sorry. 56.46 grams of C3H8. Okay. All right. Next problem. All right. I'm going to get a little bit of scratch paper so I can write a little bit bigger so you guys can see what we're doing. All right. So, second problem says we're given 0.76 moles of carbon dioxide, and it's asking us how many moles of O2. All right, this is a nice one. If you look at this one, we're starting with, and remember, we're going to call the given substance A, the unknown substance B. So we're starting at moles of A, going to moles of B. So that's just a one-step reaction. That's awesome. So if we set this up, 0.76 moles of CO2 over 1. Okay. We need moles of CO2 on the bottom and moles of O2 on the top. Okay. Then we get our numbers from our balanced chemical equation. So moles of O2 is 5. Moles of CO2 is 3. Our moles of CO2 will cancel out. We'll end up with moles of O2, which is what we're looking for. All right, so we do 0.76 times 5 divided by 3. And we get 1.27. It's hard to see that decimal place. 1.27 moles of O2. I'm going to write that in here. 1.27 moles of O2. Okay. Let's look at the next problem. All right. If 2.25 grams of O2, so I'm starting with 2.25 grams of O2, how many grams of H2O? So we're looking for grams of H2O. All right. We look at our mole map. Moles, grams of A, moles of A, moles of B, grams of B. We are starting with grams of A and going to grams of B. So this is going to be a 1, 2, 3-step problem. All right, so let's set this up. So we start with 2.25 grams of oxygen. Always over 1. All right. Now, I know because grams of oxygen is here, grams of oxygen has to go here. Okay. And this is the step I'm going from grams of A to moles of A. I'm going to use the molar mass of A. Okay. So for grams, the grams, and this is really important, grams you always have to get from the periodic table. So oxygen has a molar mass of 16 grams. So 2 of those is 32 grams. Okay. And then on top is 1 mole of O2 because 1 mole of O2 has a mass of 32 grams. All right. So let's do that math. 2.25 divided by 32 is 0.07. I'm going to go a couple more digits. 0.0, just because, you only round once, and when there's not a lot of numbers, we should probably just include them. Okay, moles of O2. Now, this becomes what we start with in step 2. Step 2, we're going to go from moles of A to moles of B using the mole ratio. All right, so this is moles of A. I know, since I have moles of O2 here, moles of O2 goes here. That's moles of A. And then moles of B is going to go on top. So moles of H2O. All right, so now we're going to look up here at our chemical reaction. Moles of O2, the coefficient is 5. Moles of H2O, the coefficient is 4. Moles of O2 cancels out. So I left my number in my calculator, so I can do times 4 divided by 5 equals 0.05625. All right, and that is moles of H2O. Okay, now that is what we start with for our final step. We're going to go from moles of B to grams of B using the molar mass. All right, so this is all over 1. I know since I've got moles of water here, I need moles of water on the bottom. Okay, and I'm using molar mass here. So 1 mole of H2O, I have to look up the mass on the periodic table. So oxygen is 16. And notice we've got 2 hydrogens, 1 oxygen. So oxygen is 16. Hydrogen is 1.01. All right, so I've got 16 plus 2.02. Oh, my puppies. I'm sorry, guys. They must see someone outside walking. So my molar mass of water is 18.02 grams. is equal to 1 mole. All right, so finally, I'm going to do my final calculation. I'm going to take this times 18.02 equals 1.01 grams of water. And double check, okay? And you should always look. Grams of oxygens cancel. And then we start with moles of oxygen cancels. And then finally, moles of water cancels, leaving us with grams of water as our unit. So the answer to this is 1.01 grams of H2O. Okay? All right. One more with this combustion reaction. Okay. So, if 11.73 grams, so my starting, what I'm given is 11.73 grams of C3H8. How many moles? So I want to know how many moles of CO2. Okay. And notice, guys, I'm not even really paying attention to the words. If you look, it gives you grams. That's the given. The number is the given. And then you just got to find how many. Okay. And that's the unknown. All right. So let's see. I'm starting with grams of A. I'm always starting with A. Have you noticed that? It's always going to be A. And then I'm ending with moles of B. So what do I do with my mole map? There we go. So we're starting with grams of A going to moles of B. So that's going to be a two-step from grams of A to moles of A, from moles of A to moles of B. All right. So let's set this up. So I feel like it's distracting with all that other stuff around. My ADHD is kicking in hard right now. All right. So I've got 11.73 grams of C3H8 over 1. All right. Now, all right, since grams of C3H8 is there, I need grams of C3H8. And then I'm going from, where's my mole map? I'm going from grams of A to moles of A. So to do that, we know up here has to be 1 mole of C3H8. And the molar mass, you know what? We looked at the molar mass before, didn't we? Yeah, look, check it out. Up here in question number 1, we figured out the molar mass of C3H8 is 44.11. So I don't have to calculate that again. 44.11 grams of C3H8. All right. So 11.73 divided by 44.11 equals 0.2, I'm going to go with 266. And that's moles of C3H8. Okay. Now that, we're trying to get to moles of B. So we've got moles of A. So to get to moles of B, we need the mole ratio. All right. So this is what we start with over 1. So we need moles of C3H8 on the bottom. And what are we looking for? We're trying to find moles of CO2, moles of B. So moles of CO2 on the top. And let's look at my balanced chemical equation. It's 1 mole of C3H8 and 3 moles of CO2. All right, so I'm going to take that number times by 3, and I will get my final answer, which I'm going to round to 0.80 moles of CO2. Okay, let's write that into our answer sheet. 0.80 moles of CO2. Okay? All right, next. What kind of reaction is this? We have KCl. It's an ionic compound, so we know it's a solid. Since it's only got one reactant, that tells us something, right? That tells us that this is what type of reaction? Hopefully, you said that this is a decomposition reaction. All right, because we have one thing, and it's breaking down to give us, what would it break down to give us? We know that when we do a decomposition reaction, it breaks down into the elements. So I have potassium plus, don't forget the plus sign, chlorine. Now, I got to think about this. I can't just leave it like that because I've got to ask a couple of questions. The first question is either one of these diatomic? Remember, we use the term Hober-Finkel as a mnemonic, HOBRFINCL. Okay, so hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, chlorine are diatomic. What that means is when they're by themselves, there are two atoms bonded together. Okay, potassium is not one of those, so it just stays as one potassium atom. The last thing we have to do is include states. So potassium is a solid, chlorine is a gas. All right, those puppies, what am I going to do with them? All right, so I need to balance, always balance. So here I've got 2 chlorine, so I'm going to put a 2 in front of KCl. Now I have 2 chlorine, but I have 2 potassium. So a 2 there, and my equation's balanced. Okay? All right, so let's just see. What does this say? How many moles of K2 can be produced by reacting 12 moles of KCl? All right, so it's giving me, I'm given 12 moles of KCl. 12 moles of KCl. And it wants to know how many moles of, this should not be K2, that should just be K. Okay, typo, a bad typo too. All right, how many moles of potassium can be produced by reacting 12 moles of potassium chloride? Where did my mole math go? Here we go. So KCl is my given, so that's my A. Potassium K is my B, is my unknown. Okay, so if I look at my mole map, I'm starting with moles of A, ending at moles of B. So it's a one step using the mole ratio. Okay, so we start with 12 moles. Slide that up a little bit. 12 moles of KCl over 1 gives me, so I need moles of KCl on the bottom so that it cancels, and I'm looking for moles of K. Okay, so 2 moles of KCl produces 2 moles of potassium. Moles of KCl cancels out. My 2's cancel out, so my answer is 12.0 moles of potassium. All right, one more. Oh, look, grams to grams. Hopefully you're starting to look at these and recognize these a little bit. And when you see grams and grams, you know that this is a 3-step problem. All right. If not, we'll use the mole map. But so we start with 21.5 grams of KCl. And we're looking, there are just typos all over in this. Let's make this 21.5 grams of Cl2. All right, so how many grams of KCl are required to make 21.5 grams of Cl2? Let's see, I'm going to get a different sheet of paper so we're not confused. All right, so we're given 21.5 grams of Cl2. And we want to figure out how many grams of KCl are needed. Okay, so if we look at our mole map, Cl2 is our given, that's A. KCl is our unknown, so that's B. Okay, so if we look at our mole map, we're starting at grams of A, ending at grams of B. Okay, so this one goes all the way, 1, 2, 3 steps. All right, so let's see if we can set this up. 21.5 grams of Cl2 over 1. Grams of Cl2 has got to go down here. So when we have grams, we know we're using the molar mass. So 1 mole of Cl2, we have to look at our periodic table to find the number of grams. So chlorine has a molar mass of 35.45, and we have 2 of them for a mass of 70.9. So 70.9 grams. So we're going to do this math. We're going to do 21.5 divided by 70.9. And that is going to give us 0.303 moles of Cl2. Okay, so grams of chlorine canceled out. Next step, we want to go from moles of A. So moles of Cl2 goes on the bottom. And we want to go to moles of B. B is KCl, so moles of KCl. Where's our equation? So 2 moles of KCl produces 1 mole of chlorine. All right, so if I do this math, and I have my numbers still plugged in, which is nice because then I'm not really rounding. So I'm just going to take this times 2, and I get 0.6064. 6064. And I'm going to write that down here. So 0.6064. Notice my moles of chlorine canceled out, leaving me with moles of KCl. Okay. And this is my final step. All right. So 1 mole goes down here. 1 mole of KCl. And we're looking for the molar mass. So we're looking for grams of KCl. That has to come from the periodic table. So potassium has a molar mass of 39.1. I'm going to write this down here in the corner. 39.1. And chlorine has a mass of 35.45. I'm going to add those together. I'm going to double check this with my calculator because I'm really good at making silly mistakes. 74.55. Good deal. So the molar mass of KCl is 74.55 grams. All right. So moles cancels out. I took my number off. So 0.6064 times 74.55 is 45.21 grams of KCl. All right, whew, there you go. So there is a walkthrough of your homework. I hope that that was helpful, and I will see you in class. Take care.